Hey, I'm Anand Chaudhary, an 8th grader from John F. Kennedy Middle School, and lately we've been talking about limits. But in this video, I want to go over how to compute limits when given a function. So why don't we get started? So here I have written limit computation, and I have a question under it. How do you find the limit when given a function? And that's the question we're going to be aiming to answer in this video. So basically, let's start off with an example. Let's not have the number one because it's our first example here. Example. Let's say we're given the limit as x approaches to 4 of x squared plus 3x plus 4. The question here is, what would you do in order to find the limit? Now, it is very simple what you do, and I'll also explain why you do it. What you basically do is, because you're trying to find what the value is going to be as x approaches to 4 of the function, you're basically just going to plug it in. So, if I were to continue to simplify this, you would basically input 4 into each x value. So it would be 4 squared plus 3 times 4 plus 4. This will end up being 16 plus 12 plus 4. After this, it's going to become, it will be 28 plus 4, and will end up being 32. Very simple how you calculate the limit. But now, what you want to understand is why we actually just input the value into here. So basically, if we imagine, let's say, though it's not going to be, let's say we're given a graph. Okay, let's like this. And this is x is equal to 4. Though this is a quadratic and it would be a parabola, I'm just using this so you guys get a visualization of this. So basically, we're trying to find it as x approaches 4. So as we know, as you might have seen from my previous videos, you have to look at a table, take numbers infinitely close to the number you're trying to get at. But if what you're trying to find is the limit, if you just plug in the number, that's basically the number you're going to get when you're using minutely small numbers. Now honestly, I use the table method to verify my answer, but when you plug it in, basically what it's saying is, let's say this is the point, okay, and we just plug it in. If we plug in the value of 4, basically what happens is you get the value of what it's going to approach to from both sides too. Because if you're right, both sides are gonna have a value very, very close to that last value. I hope that made a little bit of sense there, but it's a very interesting concept to grasp. Now we're going to do a few problems. Let's start off with our first one. We're going to try to find the limit as x approaches to 21. And this one we're just going to keep very simple of x plus x. And we want to find out what that equals to. Now, very simply, as I just said, plug in 21 for each x value. So basically I could have written 2x here too, but what would happen after this would be 21 plus 21, which is equal to 42. Final answer of 42. Very simple. Next thing we're going to do is I'm going to have a little more complex example, and we're going to see what you guys remember from my limit properties video, and we're going to use that a little bit here. So now we're going to try finding the limit as x approaches to, let's say, 3, because this is a little bit more complex here, of, let's say it's going to be 4x plus 2 divided by x plus 3. Now, and we're trying to find out what it's equal to. But if you remember from my limits properties video, I explained that when you're trying to take the limit of a division or a fraction, what happens is you can distribute the limit onto the numerator and denominator to make it much simpler. But that's only the case when if you plug the value of x in, the bottom does not equal to 0. And if you do plug it in, it's equal to 6, so we can do that. So basically what's going to happen after this, it's going to look something like limit as x approaches to 3 of 4x plus 2 divided by the limit as x approaches 3 of x plus 3. If you keep going down here and you plug in a 3 here, it would become 12 plus 2, which is equal to 14. And if you plug in a 3 here, it would equal 6. If you were to continue simplifying, it would become 7 by 3. Or if you want to do this and convert it into a into a mixed number, it would look like 2 to the 1/3. So that's basically what it would, that's what the limit of this would be. 2.3 forever. That's the decimal of 2 1/3. Again, very simple, but it's very useful to know those properties of limits, because they can help you in situations like these when you don't want to simply set. It'll just help it make it look much clearer and easier for you to understand. Now let's do a few more examples here. Number 3, we can do limit as x approaches to 12 of x squared. And we're going to find out what it equals to. Okay, again, this one I'm just going to plug in 12 here. It's going to equal to 144 because 12 squared is 144. You know, let's erase these now and try doing a few more examples, because I really do want you guys to understand, because I've been discussing about limits quite a bit lately, and I just want to make sure you guys understand the concept of limits, how to solve for them. You know, let's take one graphic one over here. If I have a graph, because it's also important to know your graphs, and let's say we're having a function something like this, and we have our value of 3. And then this goes up by 1, 2, and 3. Okay? And we're trying to find the limit as x approaches to 3 in this case. Very simply said, just look at the x value here. Okay? Because remember, it's like the same concept as when you're trying to find it out of a function. But in this case, if you do that, you can obviously see that the y value is something like 3. I was intending it for it to be 3, so it was supposed to go like that. But the value would be a 3, so in this case, the limit of x as it approaches to 3 is actually 3. Okay? I hope you guys understood that graph too. Last but not least, just a very simple one, which I'm going to do. Last one. Limit as x approaches to 100 of, let's say, x squared plus 4x plus 100. Now, if you don't remember one of our properties here that'll be really useful, you can just multiply the limit by each of these. So it would go down to being limit of x squared as x approaches to 100. You know, let me simplify it to 10 because I really don't want to do the square of 100. But x to the as x approaches to 10 of x squared plus, and remember this is our addition property. So then after this it'll also be limit as x approaches to 10 of 4x plus limit of x approaches to 10 of 100. Now I can already say off the get-go that this is automatically going to be equal to 100 because x has no impact on the value 100 because it's a constant. This, if I input 10 into x squared, you get 100 again. 10 into here plus 40 plus 100 This one is going to be 240. That's the value of this. So it's very simple how to compute the value of a limit from a function. I hope this video really did help you. Please give me feedback on the videos and subscribe to my channel. Thank you.